In today's lesson, we'll be learning how to solve similar triangles. In our first example, we want to prove that triangle ABC and triangle DEF are similar. If you recall, corresponding angles in similar triangles are equal, while the ratio of corresponding sides in similar triangles are equal. So let's try to find the corresponding angles. Angle A looks like it is equal to angle D. Angle B looks like it's equal to angle E, and angle C looks like it's equal to angle F. We don't have the exact angle measurement. However, you can take an educated guess as to which angles are equal. Next, we want to find the corresponding sides. Side AB likely corresponds to side DE. Side BC likely corresponds to side EF. And side AC likely corresponds to side DF. Next, let's write our ratio of corresponding sides. AB corresponds to side DE. Side BC corresponds to side EF. And side AC corresponds to side DF. And I'm going to place an equal sign between these ratios because the ratio of corresponding sides in similar triangles are equal. Let's see if the ratio of corresponding sides are indeed equal. So side AB is 4, side DE is 24, side BC is 5, side EF is 30, side AC is 3, and side DF is 18. At this point, you could reduce these fractions into lowest terms, or you could just throw them into your calculator and turn it into a rounded decimal. I'm going to throw it into my calculator, so that's going to be 0.17 approximately. This is also equal to about 0.17, and 3 over 18 is also equal to about 0.17. So as you can see, the ratio of corresponding sides are equal. So let's write a concluding statement. Since ratio of corresponding sides are equal, therefore triangle ABC is similar to triangle DEF. Now, we could have proved that these two triangles were similar by using the angles. However, the angles weren't given, so we were forced to use the corresponding sides. In our second example, we want to prove that triangle ABC and triangle DEF are similar. As you can see, we have two triangles which aren't exactly oriented quite nicely. So we're going to have to try to find the corresponding angles by rotating and flipping these triangles in our mind. So I would say that angle C is probably equal to angle Z. I can also see that angle B is probably equal to angle Y if you flip the other triangle. And last but not least, I would say that angle A is likely equal to angle X. Again, you'd have to rotate and flip these triangles in your mind. Next, let's look for corresponding sides. So the longest side is this side. Okay, so the corresponding side on the other triangle would be probably XZ, since that is also the longest side. All right, so let's now take a look at side AB. AB is the smallest side. So let's look at the other triangle and look for the smallest side. The smallest side is XY. And last but not least, side BC probably corresponds to side YZ. At this point, we're going to write our ratios of corresponding sides. So let's start with AC. Side AC corresponds to side XZ. We have side BC, which corresponds to side YZ. and we have side AB, which corresponds to side XY. And I'm going to put an equal sign between these ratios. At this point, we want to substitute in our values. So side AC is 8, XZ is 10, BC is 6, YZ is 7.5, AB is 4, and XY is 5. At this point, you can always reduce these fractions, or you can throw it into your calculator, and it will give you a decimal. So I'm going to throw it into my calculator. This first ratio is going to be equal to 0.8. The second ratio is going to be equal to 0.8, and the last ratio is also going to be equal to 0.8. Therefore, we can make the conclusion that these two triangles are similar. So I'm going to write, since ratio of corresponding sides are equal, therefore triangle ABC is similar to triangle XYZ. Therefore, we've just concluded that these two triangles are indeed similar. In our third example, we've been already told that these two triangles are similar. We want to determine the length of side X. How do we know they're similar? Well, corresponding angles are equal. Since we know that the corresponding angles are equal, let's try and find the corresponding sides. That side is likely corresponding to that side. This side is likely corresponding to this side. And that side is likely corresponding to that side. So let's go ahead and set up our ratios. So I don't have any labels for these two triangles, so I'm going to directly use the side lengths. That would give me 8/4. And I would also have 4/x. And I would also have 6/3. And in between, I should be using equal signs. If we want to figure out the value of x, that means we're going to be using this ratio. We're also going to be needing one other ratio. You can either use 8/4 or 6/3. You can use either of them. I'm going to choose to use 8/4. Okay? So I'm going to rewrite that. 8/4 is equal to 4/x. Okay? Now, to figure out what x is equal to, you need to cross multiply. So you will eventually get 8 multiplied by x equals 4 times 4. Okay? You can simplify some of these numbers. For example, I don't need that dot anymore, and 4 times 4 is 16. At this point, you want to isolate x, but x is stuck with multiply by 8. What is the opposite of multiply by 8? The opposite is divide by 8. So I'm going to divide both sides by 8. Those 8's cancel out, so x is equal to 16 divided by 8, which is 2. Therefore, the length of side x is 2 units. And I don't know if that's centimeters or meters because it's not specified, so we can just say 2 units. In our fourth example, we've been told that triangle ABC is similar to triangle DEF. So that means corresponding angles are equal and ratios of corresponding sides are equal. Right off the bat, I can see that angle A and angle D are probably equal. Angle B and angle E are definitely equal since they're both 90 degrees, and angle C and angle F are also equal. Next, I want to identify my corresponding sides. Well, side AB is likely corresponding to side DE. Side BC is likely corresponding to side EF, and side AC is likely corresponding to side DF. At this point, let's write our ratio of corresponding sides. So I have side AB, which corresponds to side DE. Side BC corresponds to side EF. and side AC corresponds to side DF. So I'm going to add some equal signs between these ratios. At this point, all you need to do is substitute in your known values. I know that AB is 36 units. I want to figure out the value of DE, so I'm just going to leave it as DE. BC is 9 units, EF is 6 units. I have no idea what side AC is or what side DF is. So I want to solve for the side length of DE. I'm also going to be using this ratio. The last ratio of AC over DF is completely useless because it has no numbers in it. So let's go ahead and rewrite 36 over DE equals 9 over 6. At this point, we want to cross multiply. So I'm going to have 36 multiplied by 6 and DE multiplied by 9. I can simplify 36 times 6. That becomes 216. And the DE multiplied by 9 stays exactly the same. Remember, you want to isolate DE, but DE is stuck with this multiply by 9. What is the opposite of multiply by 9? It is divide by 9. So I'm going to divide both sides by 9 to get rid of that. So I'm going to get 216 divided by 9. You can just throw that into your calculator and you should get 24 is equal to DE. Therefore, the side length of DE is approximately, or not approximately, it is exactly 24 units. In our fifth example, we've been told that triangle ABC is similar to triangle PQR. We also want to determine the length of side PR and PQ. Since these triangles are similar, that means that corresponding angles are equal. Let's identify these corresponding angles. Angle A and angle P are probably equal. Angle B and angle Q are equal. And angle C and angle R are probably equal. Next, let's identify the corresponding sides. AB corresponds to side PQ. BC corresponds to side QR, and AC corresponds to side PR. So let's go ahead and write our ratio of corresponding sides. I have AB, which corresponds to side PQ. I have side BC, which corresponds to side QR. And I have side AC, which corresponds to side PR. I'm going to add in some equal signs. And then I'm going to substitute in my known value. So AB is 4 units. PQ is unknown, so I'm going to leave it as PQ. BC is 6 units. QR is 12 units. AC is 7 units. And PR is unknown, so I'm going to leave it as PR. At this point, we want to figure out the length of side PR and PQ. So I'm going to be using this ratio for sure. And how do I know what other ratio I should use? Well, I want to use a ratio which has 2 numbers in it. So the 6 and 12. Okay, so let's go ahead and use those numbers down here. So I have 4 over PQ is equal to 6 over 12. At this point, you want to cross multiply. So I have 4 multiplied by 12 equals to 6 multiplied by PQ. At this point, you can simplify some of your numbers. So 4 times 12 is 48. The 6 multiplied by PQ stays exactly the same. To get rid of the 6, you need to do the opposite operation, which means we need to divide both sides by 6. So those 6's disappear, and 48 divided by 6 is 8. So PQ is 8 units long. We still need to figure out the length of side PR. So we're going to be using these two ratios. So I want to use 6 over 12 and 7 over PR. Let's rewrite that over here. 6 over 12 equals 7 over PR. At this point, you want to use the same technique. You want to cross multiply. So that means I have 6 multiplied by PR equals 7 multiplied by 12. You can just simplify some of these numbers. 7 times 12 is 84. And the 6 times PR stays exactly the same. To get rid of the 6, you need to do the opposite operation, which means you're going to divide both sides by 6. those 6's cancel out. So the side length of PR is 84 divided by 6. You can throw that into your calculator, and that means PR has a side length of 14 units. So as you can see, this is basically 2 questions in one, but it is not very different from the previous questions you've done.